As of June 8th, 2023, the planet Saturn has 146 moons, which is more moons than any other planet in the solar system. These moons range in size from larger than the planet Mercury to as small as a sports arena. They also differ in their composition. Some are icy giants with subsurface oceans, and others are very small, rocky worlds covered in craters. 7 of Saturn's moons are so bright that you can see them from Earth through a telescope: Titan, Rhea, Tethys, Dione, Enceladus, Iapetus, and Mimas. The moons Titan and Enceladus are considered important destinations for future deep space missions because of their possibility of holding life. The moons of Saturn are also closely tied to the planet's ring system. They shape, contribute to, and collect material from the rings. Some act as shepherds, keeping the rings in place. Others have cleared gaps in the rings through their gravitational effects. Now, obviously, I won't be talking about every single moon of Saturn. That would be ridiculous. There's just too many for me to cover in one video. I just don't have it in me. Plus, a lot of them are very small and fairly insignificant, so if I were to talk about every single one of them, a lot would start to sound like repeats. I'll just be covering some of the more important and interesting moons. So without further ado, let's fly right into the moons of Saturn. With an average diameter of 3,200 miles, Titan is the largest moon of Saturn. It's larger than the planet Mercury and the second largest moon in the entire solar system. The only moon that beats it out is Ganymede from Jupiter. Titan was the first moon of Saturn to be discovered, as it was found by Christian Huygens on March 25th, 1655. The Huygens lander, which launched with the Cassini spacecraft and landed on the surface of Titan, was named after this discoverer. Titan orbits around 759,000 miles from Saturn, and it takes about 15 days and 22 hours to complete one orbit. It's tidally locked, so it only ever shows one side of itself to its host planet. It orbits roughly along Saturn's equatorial plane, and its tilt relative to the Sun is about the same as Saturn's, so it also experiences seasons on the same schedule as its planet. Notably, Titan is the only moon in the solar system known to have a substantial atmosphere. A shell of nitrogen and methane extends around the moon about 10 times farther than Earth's atmosphere does around it. Sometimes it falls back to Titan's surface as methane rain. Besides Earth, Titan is the only place in the solar system that has liquids on its surface in the form of lakes, rivers, and seas. It is said to somewhat resemble the way Earth looked early in its history. These liquids mostly come in the form of hydrocarbons like methane and ethane. The largest seas are hundreds of feet deep and hundreds of miles wide. Look beneath Titan's thick water ice crust and you'll find more liquid. This subsurface ocean is made primarily of water instead of methane. Between the underground ocean and the surface, we find an interesting contrast. The subsurface water could harbor life as we're used to it, while the hydrocarbon liquids up above could hold life with entirely different chemistry from what we know. Or, Titan could be completely lifeless. That's also an option. No actual evidence of life has been detected on the moon. It just has environments that are capable of supporting it. A model based on data from the Cassini-Huygens mission suggests that Titan is made up of 5 primary layers. First, there's a core of rock, specifically water-containing silica rock. Outside that is a shell of water ice. This ice is a special type called ice 4 that is only found at extremely high pressures. Salty liquid water surrounds the shell of ice, and outside of that is a crust of even more ice. Finally, there's the surface, which is coated in organic molecules that rained or otherwise settled out of the atmosphere in the form of sands and liquids. Titan's surface is one of the most Earth-like places in the solar system. It's much colder, though, to the point that ice plays the role of rock. It might have some volcanic activity, but because of the low temperatures, lava would come in the form of liquid water instead of molten rock. The surface of Titan has few visible impact craters, which suggests that the surface is rather young. Some process or combination of processes has probably eroded away or erased other impact craters over time. Existing volcanic activity could contribute to this. Titan's atmosphere is about 95% nitrogen, 5% methane, and very small amounts of carbon-rich compounds. High up in the atmosphere, UV radiation from the sun and high-energy particles accelerated in Saturn's magnetic field split apart molecules of nitrogen and methane. The pieces of these molecules then recombine to form a variety of organic chemicals, some of which contain key elements for life on Earth. Some of the compounds produced by this splitting and recycling create a sort of hazy smog around Titan that make it difficult to view the surface. That's why pictures of Titan often look very bland and yellow. The methane in the atmosphere is what makes this complex chemistry possible, but its source is mostly unknown. Sunlight breaks it down, so some source must be replenishing it if it hasn't gone away. It could be belched into the atmosphere by cryovolcanism, but aside from that, the origin of Titan's methane is undecided. Rhea was discovered by Giovanni Cassini on December 23rd, 1672. It's the second largest moon of Saturn, but with an average diameter of 950 miles, it is much smaller than Titan. Rhea is a small, cold, and airless body, and it's pretty similar to the moons Dione and Tethys. It orbits about 327,500 miles from Saturn, and it's tidally locked with a 4.5-day orbit. Composed of ice and rock, it's heavily cratered. Because of its high reflectivity, Rhea's surface is likely made of water ice. The entire moon is thought to be a homogeneous mixture of ice and rock. Features on Rhea can be divided into two regions. First, there's heavily cratered terrain with craters larger than 25 miles across. Second, there's areas in the polar and equatorial regions with craters less than 25 miles across. The difference between these two regions indicates a major resurfacing event at some point in Rhea's history. This resurfacing would have occurred long ago, as there are very few young craters with rays extending from them. The average age of the moon's plains is thought to be about 4 billion years. Rhea also has subsidence fractures which make canyons, some of which are several hundred meters high. The walls of these canyons are bright because darker material falls off to expose water ice. These fracture cliffs show that Rhea might have been tectonically active in the past. In 2010, the Cassini spacecraft detected a thin atmosphere, or an exosphere, composed of oxygen and carbon dioxide. This marked the first time a spacecraft directly captured molecules of an oxygen atmosphere somewhere outside of Earth. The oxygen appears to originate from times when Saturn's magnetic field rotates over Rhea. Energetic particles that are trapped in the field hit the moon's surface. This causes chemical reactions that decompose the surface and release oxygen. The source of the carbon dioxide in the atmosphere, on the other hand, is less certain. Scientists aren't sure where it comes from. In 2008, Cassini found evidence of material orbiting Rhea. This marked the first time that rings were found around a moon. Instruments on the spacecraft detected a broad debris disk and at least one ring. So yeah, there's a ringed moon orbiting a ringed planet. Isn't that neat? Iapetus was discovered by Giovanni Cassini on October 25th, 1671. Cassini could only see Iapetus when it was on the west side of Saturn. From this, he correctly concluded two things. Iapetus has one side that's much darker than the other, and it's tidally locked with Saturn. Iapetus has an average diameter of 914 miles. It orbits about 2.2 million miles from Saturn. Because its orbit is very distant and inclined, it is the only large moon with a nice view of Saturn's rings. Iapetus is thought to be composed of ice and rock. Its high contrast surface of light and dark has caused it to be dubbed the yin and yang of Saturn's moons. The leading hemisphere, which is the one that faces the direction of its orbit, is much darker than the trailing hemisphere. There's plenty of theories about why Iapetus has a dark side and a light side. It could be sweeping up particles from Phoebe, a dark moon that orbits much further away. Ice volcanism could also distribute darker material to the surface. In 2007, a Cassini flyby showed that a process called thermal segregation is probably most responsible for this dark hemisphere. Iapetus rotates very slowly. It takes more than 79 Earth days to complete one rotation. This slow rotation means that its daily temperature cycle is very long, so darker material can absorb heat and warm up. This heating causes any volatile or icy species within the dark material to sublime out and move to the colder regions of the moon. The sublimation causes the dark material to become darker and the light material to become lighter. Iapetus could have experienced an influx of dark material from an external source. The arrival of this material could have warmed up and triggered thermal segregation. Iapetus also contains some of the highest mountains in the solar system. A chain of 6-mile-high mountains stretches along its equator. On the side opposite Saturn, this ridge appears to break up, making distinct mountains visible. These are informally referred to as the Voyager Mountains because of encounters with Voyagers 1 and 2 that brought about the first knowledge of these mountains. There are two theories on how this ridge formed. It might have formed at an earlier time when Iapetus rotated much faster than it currently does. Or it could have come from some material that was left over from the collapse of a ring. Dione was discovered by Giovanni Cassini on March 21st, 1684. It has an average diameter of 698 miles. It orbits at a distance of 234,500 200 miles, has a 2.7-day orbit, and is tidally locked to Saturn. Dione is a heavily cratered moon with a dense core. It's likely composed of silicate rock with a small portion of ice. Very fine powder from Saturn's E-ring is constantly bombarding this moon. Dione's features include heavily cratered terrain, moderately cratered plains, and fractured areas. Some of the larger craters are as much as 62 miles across. Interestingly, Dione is more heavily cratered on its trailing hemisphere than its leading hemisphere. This is odd. The leading hemisphere of a body is usually more heavily impacted than its trailing hemisphere because it faces impactors head-on. So why is this moon the opposite of that expectation? Scientists have theorized that a recent impact could have spun Dione upside down, but there's no explanation for why it spun exactly 180 degrees. The fractured areas of Dione can be 10 to hundreds of miles long. They often cut through plains and craters. The bright ice walls of canyons are probably caused by subsidence cracking, much like on Rhea. Dione has gravitationally locked two other moons, Helene and Polydeuces. Helene orbits Saturn 60 degrees ahead of Dione, while Polydeuces orbits 60 degrees behind it. Dione is also in an orbital resonance with Mimas and Enceladus. The three moons speed up slightly as they approach each other and then slow down as they draw away. These interactions cause the orbits to vary slightly in a long series of complex changes. This resonance also helps keep them locked in their positions. Dione keeps Enceladus locked at a period exactly half that of its own orbital period. For every time Enceladus orbits once, Dione orbits twice. Tethys was discovered by Giovanni Cassini on March 21st, 1684. It has an average diameter of 662 miles. Orbiting about 183,000 miles from Saturn, it completes an orbit every 45.3 hours, and it's tidally locked. Tethys is very similar to its sister moons Dione and Rhea, but it's not as heavily cratered as the other two. Because it travels close to Saturn, it feels the planet's gravitational pull particularly strongly. Heat from Saturn might allow the moon's icy surface to melt slightly, which fills in craters and other signs of impacts. Tethys is likely composed almost entirely of water ice with a very small amount of rock. Its surface is highly reflective and is also made mostly of, you guessed it, water ice. The northern hemisphere of Tethys is lighter in color and has been heavily reworked from ages of bombardment. For example, near the prominent peaked crater Telemachus are the remnants of Terrasius crater. This ancient impact site has been so badly overprinted and eroded by other impacts that only a circular pattern of hummocks indicates the old crater rim. It's basically been almost completely buried underneath other craters. Closer to the equator of Tethys, the terrain is darker and has fewer craters. This suggests past internal activity and resurfacing of the terrain that removed old craters. Tethys features the Odysseus crater, which covers nearly 2/5 of its diameter. Such a huge impact could have shattered a solid body, so it's likely Tethys was still partially molten at the time of the impact. The crater's rim and central peak have mostly collapsed, leaving a very shallow crater. On the other side of Tethys from the crater is a large trench called the Ithaca Chasma. It runs diagonally from the North Pole to the South Pole and covers about 3/4 of the moon's circumference. It's 62 miles wide, 2 to 3 miles deep, and extends for 1,200 miles. It might have been caused by the expansion of internal liquid water as it froze into ice after the surface had already frozen. An alternative theory, however, blames the impact that created Odysseus crater. The surface of Tethys features strange red arcs that scientists can't yet explain. They've just got no idea what those arcs are. Tethys has gravitationally locked two smaller moons, Telesto and Calypso, in its own subsystem. This is the same sort of arrangement that Dione has with Helene and Polydeuces. The three moons complete their orbits around Saturn as one moving unit. They're spaced in 60-degree intervals, with Telesto first, Tethys second, and Calypso third. Enceladus was first discovered on August 28, 1789 by William Herschel. It has an average diameter of 313 miles. It orbits 148,000 miles from Saturn between the orbits of Mimas and Tethys. It's tidally locked and completes one orbit every 32.9 hours. It's located within the densest part of Saturn's E-ring. Dione's gravity stretches the orbit of Enceladus into an elliptical shape. This means it's sometimes closer to Saturn and sometimes further away. This causes tidal heating within the planet. Enceladus has the whitest and most reflective surface in the entire solar system. Parts of it show craters up to 22 miles in diameter, while other regions have few craters. This indicates major resurfacing events in the moon's past. The south polar region in particular particular is almost entirely free of craters. Instead, it's littered with house-sized boulders and regions carved by tectonic patterns that are unique to this region of the moon. Like Titan, Enceladus features a subsurface ocean beneath its icy crust. The moon spews this ocean out into space. In 2005, Cassini found icy water particles gushing from the moon's surface at 800 miles per hour. The ejected material forms the E-ring of Saturn. Only a small fraction of the material actually ends up in the ring, though. Most just falls back to the surface of Enceladus like snow. The jets of water come from relatively warm fractures in the crust that are informally dubbed tiger stripes. Around the plume of water is a gaseous envelope. Water vapor, carbon dioxide, methane, and perhaps a little ammonia and either carbon monoxide or nitrogen gas make up this envelope, along with some salts and silica. The icy shell covering the ocean supplying these jets could be as thin as half a mile to 3 miles at the South Pole. This is much thinner than the average global thickness, which is thought to be about 12 to 16 miles. Because the material in the E-ring comes from within Enceladus, studying the material in the ring is basically the same as studying the moon's subsurface ocean. Nanograins of silica have been found in the E-ring, suggesting the presence of hydrothermal vents within the ocean. With its global ocean, unique chemistry, and internal heat, Enceladus has become a possible candidate for finding life outside of Earth. Mimas was discovered by William Herschel on September 17, 1789. With an average diameter of 246 miles, it's the smallest and innermost of Saturn's major moons. It's not quite big enough to hold a round shape, so instead it's kind of shaped like an egg. Mimas orbits at an average distance of just over 115,000 miles from Saturn, and it takes only 22 hours and 36 minutes to complete an orbit. Like most major moons, it's tidally locked to Saturn. Mimas is composed mainly of water ice, which is the only material to have ever been detected on the moon. Most of its surface is covered in impact craters ranging up to greater than 25 miles across. Craters in the South Pole region, however, are generally less than 12.4 miles. This suggests some melting or other resurfacing process occurred in the South Pole later than on other regions of the moon. The moon's most notable feature is Herschel Crater, which is named for its discoverer. This crater has led to Mimas being compared to the Death Star from Star Wars. It stretches a third of the way across Mimas. It's 80 miles across, and its outer walls are 3 miles high. The impact that caused it probably came pretty close to breaking poor Mimas apart. Shockwaves from the impact could have caused fractures on the moon's opposite side. Mimas orbits closer to Saturn than Enceladus and has a much larger eccentric orbit. So, in theory, it should receive more tidal heating than Enceladus. But while Enceladus displays evidence of internal heat through its geysers of water, the heavily cratered surface of Mimas implies that it's been frozen for a long time. It doesn't have the same internal heat. This has given rise to something called the Mimas test. It states that any theory claiming to explain the partially thawed water of Enceladus must also explain the entirely frozen water of Mimas. 3 people are credited with the discovery of Hyperion. First, there's William Lassell, who discovered the moon on his own in 1848. In the same year, William Cranch Bond and his son George Phillips Bond independently discovered the same moon. All 3 are considered Hyperion's discoverers. Hyperion was the last of Saturn's major satellites to be discovered. It's very irregular in shape, and its average diameter along its axes is 255 by 163 by 137 miles. It's the largest of Saturn's irregular, non-spherical moons. Hyperion has a sort of spongy texture. Scientists suggest that its strange shape could be a sign that it's a remnant of a larger moon that was destroyed by an impact. Hyperion is not very dense. Its average density is only slightly more than half that of water. This could be due to the moon being made of water ice with a porosity of about 40%. Porosity is basically a measure of how much of something's volume is taken up by gaps or pockets of air. But the low density could also come from the presence of lighter materials like frozen methane or carbon dioxide. Hyperion's low density is consistent with the idea that the moon accreted from a number of icy and rocky bodies, but it just doesn't have enough gravity to compact them. In this way, it would be similar to a large pile of rubble just floating through space. Hyperion's rotation is very odd and irregular, and it sort of just tumbles through space on an unpredictable path. It orbits at an average distance of 933,000 miles from Saturn, although its orbit is highly eccentric. This unusual orbit contributes to the variations in its rotation. What has a stronger effect on Hyperion's rotation, though, is its resonance with Titan. Saturn's largest moon apparently keeps Hyperion's orbit eccentric and prevents it from becoming more circular over time. The odd moon's great distance from Saturn and its resonance with Titan have prevented it from becoming tidally locked. It rotates roughly every 13 days and orbits Saturn every 21 days. Hyperion features a deeply cratered surface. Because it's so far from Saturn, there's not enough tidal heating to blur or erase old features like impact craters. Hyperion's craters are particularly deep and they don't have significant rays of ejecta. This could be because its high porosity and low density leads to impact craters compressing the moon's surface rather than excavating it. Prometheus and Pandora are moons associated with Saturn's F ring. They were both discovered by the Voyager team in 1980. Prometheus is extremely irregular and has many visible craters, some of which are up to 12.4 miles in diameter. There are a number of ridges and valleys on its northern side. It has an average radius of 26.8 miles. It orbits about 87,000 miles from Saturn and takes 14.7 hours to complete an orbit. Pandora's average radius is about 25.3 miles, which makes it a little bit smaller than Prometheus. It orbits 88,000 miles from Saturn and completes an orbit in 15.1 hours. It's sort of potato-shaped and covered in fine icy material. Even its craters are coated in debris. Grooves and ridges appear to cross its surface. Prometheus is what's called a shepherd moon. It constrains the extent of the inner edge of Saturn's F ring. Pandora was long thought to also be a shepherd of the F ring, but it actually isn't. Instead, it tends to disrupt the ring while Prometheus keeps it in place. On December 15th, 1966, Adeline Dolphus observed a moon and proposed the name Janus for it. Just 3 days later, Richard Walker made a similar observation that is now credited as the discovery of Epimetheus. At the time, astronomers believed there was only one moon, unofficially known as Janus, in that orbit. But 12 years later, in October of 1978, Stephen M. Larson and John W. Fountain realized that these strange observations from 1966 could be best explained by the presence of two distinct objects sharing the same orbit. This was later confirmed by Voyager 1 in 1980, which means both Janus and Epimetheus coexist. Janus is a strangely shaped moon with an average radius of 55.6 miles. Its average dimensions are 122 by 119 by 93 miles. It's extensively cratered, with some craters larger than 19 miles across. Some of its prominent craters are named Castor, Phoebe, Itis, and Lynceus. It orbits 94,000 miles from Saturn in the gap between the F and G rings, and it takes 17 hours to complete an orbit. Epimetheus is also oddly shaped, though it's smaller than its partner. Its average radius is 36 miles, and average dimensions are 84 by 65 by 65 miles. Its shape reflects a pronounced flattening at the South Pole that's associated with a large crater. It has several craters larger than 19 miles, including Hilaria and Pollux. Like Janus, it orbits 94,000 miles from Saturn and takes 17 hours to go all the way around. Janus and Epimetheus are the 5th and 6th moons in terms of distance from Saturn, and both are tidally locked. They're thought to be composed of mostly water ice, but their density is about 70% that of water. This means they're likely rubble piles similar to Hyperion. Janus and Epimetheus are interesting because of the weird orbital dance they do with each other. One moon orbits 31 miles further from Saturn than the other, which means it takes a little more time to complete one orbit. This slight difference means the inner, faster moon starts to catch up to the other one every approximately 4 Earth years. When this happens, the gravitational interaction between the two causes them to trade places. The outer moon becomes the inner, and the inner becomes the outer. The closest the two get to each other is about 6,200 miles. This is the only orbital configuration of its kind known in the entire solar system. Janus and Epimetheus might have formed from the breakup of another larger moon. This would have happened early in the life of the Saturnian system. Both moons trail enough particles to form a faint ring, although this ring isn't visible except to very powerful telescopes. The region of their common orbit instead appears like a clean gap between the F and G rings. The ring formed from the moons is appropriately called the Janus/Epimetheus ring. Phoebe was discovered in August of 1898 by William Pickering. It was the first target encountered upon the arrival of the Cassini spacecraft in the Saturnian system in 2004. Because of of this, it's unusually well studied for an irregular moon of its size. Phoebe orbits at a distance of over 8 million miles from Saturn. This is almost 4 times the distance of its nearest neighbor Iapetus. Phoebe and Iapetus are also the only major moons that don't orbit close to the plane of Saturn's equator. Phoebe is roughly spherical with an average radius of 66.2 miles. It rotates on its axis every 9 hours and completes an orbit around Saturn every 18 Earth months, so it's not tidally locked. It also has a retrograde orbit, which means it orbits in the opposite direction of Saturn's rotation. Phoebe is very dark and reflects only 6% of the sunlight it receives. This darkness and its irregular retrograde orbit suggests that Phoebe is a captured object. That means it's something that Saturn just pulled into orbit around it as it flew by. Dust from impacts on Phoebe are the source of Saturn's outermost ring, which is aptly called the Phoebe ring. This ring extends from 4.6 to 7.4 million miles around Saturn, and it's the largest planetary ring in the entire solar system. And those are the moons of Saturn. Well, some of them, at least. There are so many moons, and I suffered a lot when I was carrying out the research for this video. The names of Saturn's moons are obviously primarily taken from Greco-Roman mythology, but in recent years scientists have also begun taking names from Inuit, Gallic, and Norse mythology as well. So that's pretty cool. Obviously I didn't talk about every single moon because why would I do that to myself? There's 146 moons, and a lot of them are pretty similar, so cut me some slack. The moons are very interesting, though. I get why Saturn is mostly known for its rings, but the moons are really cool, too. Anyway, that's about it. I've said all that I need to say. Thanks for watching, like and subscribe if you enjoyed, and have a good day.